Okay, so in this video we're going to be looking at warm-up for day number 6. Okay, and this is going to be a really quick video because we're just drawing some free body diagrams and answering some questions about net force. Okay, so take a look at question number 1. Question number 1 basically says draw a free body diagram, draw an FBD for the following situations. 1A says a ball is dropped off a building and is in free fall. Now, we talked about this in another video, but remember, an object that is in free fall, okay, by definition, the only force acting on it is the force of gravity. Okay, so when I see that the ball is in free fall, okay, that's a context clue. Okay, so I'm going to use that. Okay, I have the force of gravity acting on the ball, and that's it. So, force of gravity acts down, the dot represents the object, I label that FG, and I'm done. And by the way, it says ignore air resistance, but as long as you know free fall means the only force acting is the force of gravity, it's still an easy FBD to draw. Okay, 1B says a ball is dropped off a building and falls at a constant velocity. Do not ignore air resistance. That's a big hint if ever there was one. Okay, that's basically telling you, hey, there's air resistance. Okay, so the ball is falling, it's close to the surface of Earth, so we have force of gravity. There is no surface, that means there's no normal force. There's no rope or string, so no tension. Because there's no surface, there's also no friction, but there is air resistance. And the fact that's constant velocity means, because of Newton's first law, the only way it's allowed to move at a constant velocity is if the net force is equal to 0. Remember, if the net force is 0, that means either the object is at rest or moving at a constant velocity. Okay, so how do we get a net force of 0 if we have a force going down? Well, we have to have another force going up with the same size in the opposite direction to cancel out the force of gravity. So I'm going to call that F air for air resistance. Okay, and that's it for 1B. 1C, a car driving on a rough surface. Look for these context clues, by the way. Number 1, there's a surface. That means there's going to be a normal force. Anytime you have a surface, you have a normal force automatically. And if it's a rough surface, that means there's friction. Okay, so the car is moving forward. Okay, let's say the car is moving to the right. We have force of gravity going down. Okay, because we have a surface, we have a normal force coming out at a 90-degree angle from the surface, just like this. Notice that Fn and Fg cancel each other out. Now, if the car is moving to the right, okay, that means the force of friction is going to act to the left. Right? Now, how do I know it's moving to the right? I don't know that. I just made that up. Okay? If I had said it's moving to the left, then friction would be to the right. Okay? Now, here's the issue. If it's moving at a constant velocity, because of the first law, that means that the net force is equal to 0. Okay, this is not going to give me a net force of 0 because Fn and Fg are going to cancel each other out, but Ff is unbalanced. So I have to have a force going in the direction opposite of friction, okay, with the same size so that they all cancel out. And where's that force coming from? Probably the car engine. So I'm just going to write F engine. And if you wrote F applied, that would be fine as well, because the force is being applied by the engine. Okay, so there you go. That is 1C. Pause there if you need to look at those. Okay, and then question 2, for each of the FBD shown below, calculate the net force and state whether the object is accelerating or moving at a constant velocity. Okay, this just has to do with the net force. If the net force is not equal to 0, if F net is not equal to 0, that means the object is accelerating. If it's moving at a constant velocity, because of the first law that we talked about in the previous video, that means the net force is equal to 0. Okay, so let's check this out. This one, 2A, we've got 25 newtons going down, 25 newtons going up. Those two, when you add them together, are going to cancel each other out, right? Because this is like a 25 plus a negative 25. Remember, net force is what you get when you add up all the forces acting on an object. So 25 plus negative 25 cancels out. 20 plus negative 20, okay, cancels out. And so this is going to have a net force of 0. And so this object is moving with a constant velocity. I'm just going to write CV for constant velocity. For 2B, Okay, the 25 and the negative 25 newtons cancel each other out, but now I've got 20 plus negative 15. This is negative 15 because it's going to the left. Okay, now I don't know what these individual forces are, but that doesn't matter. Okay, I do know that the net force is going to be 5 newtons to the right, and therefore, because it's not equal to 0, this object is accelerating. Okay, to C, I've got 25 newtons going up plus negative 25 newtons going down. This one is going to have a net force of 0 because those two forces are going to cancel. That means it's moving with a constant velocity, or it could be at rest. I don't know. It just says in the question to state whether the object is accelerating or moving at a constant velocity, but it's also possible it's at rest if the net force is 0. Remember, there's no way to look at an FBD and know if the object is at rest or if it's moving at a constant velocity. Okay, those are both two possible options. And 2D, this net force is going to be 20 newtons to the right because the 25 and the negative 25 are going to cancel out. Again, the 20 is unbalanced, and so the net force is basically going to be 20 newtons to the right, and so this object is going to be accelerating. Okay, so really easy warm-up question today. Hopefully all of those made sense. Pause it there if you need to. Let me know if you have any questions, and as always, I will see you guys in the next video.